Slide 1. In this presentation, I will demonstrate a one-way ANOVA using SPSS to determine whether there is a statistical significant difference in district enrollment across selected regions. The data set used for this analysis is the statewide school district data file. The analysis focuses specifically on Region 1, Region 2, and Region 5. This presentation follows APA reporting standards and includes assumption testing and effect size interpretation. In slide 2, I will be explaining the research question and variables. The research question for this analysis is whether there is a statistical significant difference in district enrollment between Region 1, Region 2, and Region 5. The dependent variable in this analysis is the district enrollment labeled as enrollment in the data set. The independent variable is the region, which is a categorical variable. Although the data set contains 5 regions, only 3 regions were included in this analysis as required by the assignment instructions. Slide 3, data preparation, filtering regions. Before conducting the analysis, I filtered the data set to include only regions 1, regions 2, and 5 in SPSS. This was done by selecting data, then selecting cases, and applying the conditions where the region's variable was equal to 1, 2, or 5. This ensured that the district form from other regions were excluded from the analysis without deleting the data. In slide 4, I will be explaining the assumption test overview. Before running a one-way ANOVA, 2 main assumptions must be checked: normality of the dependent variable within groups and the homogeneity of variances across groups. Normality was assessed using the Shapiro-Wilks test, and homogeneity of variance was assessed using the Levine test. Even if these assumptions are valid, the analysis proceeds as instructed. In slide 5, I will be explaining the normality assumption, Shapiro-Wilks test. To assess normality, I examined the Shapiro-Wilks test results for district enrollment within each region. The Shapiro-Wilks test produced a significant value of p less than 0.001. Since this value is less than 0.05, the assumption of normality is not met. Despite this outcome, I proceeded with the ANOVA because the test is robust to violations of normality. In slide 6, I will be explaining the homogeneity of variance. I assessed the homogeneity of variance using the Levine test. The Levine test signifies value was p equals 1.42. Because this value is greater than 0.05, equal variances are assumed. Therefore, the standard one-way ANOVA was conducted as the appropriate statistical test. In slide 7, I will be explaining the running a one-way ANOVA in SPSS. After checking the assumption, I ran the one-way ANOVA in SPSS by selecting Analyze, Compare Means, and One-Way ANOVA. District enrollment was entered as a dependent variable, and region was entered as the factor. Descriptive statistics and the homogeneity of variance tests were selected before running the analysis. In slide 8, we will be explaining the ANOVA results. The ANOVA output shows the comparison of mean district enrollment across Region 1, Region 2, and Region 5. The F statistics for this analysis is 4.12. with 2 degrees of freedom between groups and 90 degrees of freedom within groups. The associated p-value is 0.018. In slide 9, we will be explaining the hypothesis decision. Since the p-value is less than 0.05, the results are statistically significant. Therefore, I rejected the null hypothesis. This indicates that there is a significant difference in district enrollment among the 3 regions. In slide 10, I will be explaining the APA style reporting. In proper APA format, the one-way ANOVA results are reported as follows. An F-test with 2 and 90 degrees of freedom was statistically significant, equals 4.12, and P is 0.018. In slide 11, I will be explaining the effect size, eta square. To assess practical significance, I calculated the effect size using the eta square. The eta square is calculated by dividing the sum of squares between groups by the total of sums of squares. The eta square value for this analysis is eta square equals 0.084. In slide 12, I will be explaining the effect size interpretation. An eta square value of approximately 0.01 indicates a small effect. Around 0.06 indicates a medium effect, and a value greater than 0.14 indicates a large effect. Based on the calculation, eta square value of 0.084, this represents a medium effect size. This means the difference in the district enrollment is moderately important. In slide 13, I will be explaining the summary of findings. This analysis examines where the district enrollment differs across Region 1, Region 2, and Region 5 using a one-way ANOVA. After filtering the data and checking the assumptions, the ANOVA results show that there is a statistical significant difference in the enrollment across the regions. The null hypothesis was rejected, and the effect size indicated a medium partial impact. This suggests that while there is a statistical significant difference, the magnitude of the difference is moderate. In slide 14, I will be concluding. This presentation demonstrates the correct procedure for conducting a one-way ANOVA in SPSS, including assumptions, testing, hypotheses evaluation, APA style reporting, and effect size interpretation. These steps ensure both statistical accuracy and meaningful interpretation of results.